Hello students, Ncert Solutions, Class 11th Physics. Chapter is Gravitation. Question number 25. A rocket is fired vertically from the surface of Mars with a speed of 2 km per second. If the 20% of its initial kinetic energy is lost due to the Martian atmospheric resistance, how far will the rocket go from the surface of the Mars before returning to it? Given the mass of the Mars is 6.4 into 10 to the power 23 kg, radius of the Mars is this 3395 km, and capital G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. In this question given that here suppose this Mars and let the mass of the Mars mm, and this is the radius of Mars rm, and a rocket is fired from point A. Rocket is projected vertically upward. Here this rocket having mass small m is fired with velocity v, and let its maximum height, this h, before returning. This point is B here suppose, and this is maximum height h, and therefore here the final velocity of the rocket is 0. Final velocity of the rocket is 0. Now given that the initial speed v is equal to initial speed of the rocket is, this is with a speed of 2 km. So this is 2 km per second means 2 into 10 to the power 3 meter per second. Now using principle of conservation of energy, using conservation of energy, that is total energy at point A should be equal to total energy at point B. Here this is kinetic energy half mv square, but 20% of this initial kinetic energy lost due to the Martian atmospheric resistance. 20% lost होते हैं, therefore remaining is 80%. This remaining is 80%, and this is the kinetic energy at point A. And now the potential energy at gravitational potential energy at point A is minus gmm upon this Rm. This is the gravitational potential energy at point A. Now total energy at point B is minus gmm upon this Rm plus h. This is unsolving. M से m cancel both sides. Now this is 80% means 80 upon 100, and this is 0.4. This is 0.4 here, 0.4 v square minus this gmm upon this Rm is equal to minus gmm upon this Rm plus h, or this can be written as, this is 0.4 v square is equal to, this side is here, so therefore this is gmm upon Rm minus this minus here, ये यहाँ पर plus, and this is minus as it is. This is g mm upon this Rm plus h. Now this is 0.4 v square. 0.4 v square is equal to g mm is common. Take outside. So this is 1 upon Rm minus this is 1 upon Rm plus Rm plus h. Now this point 0.4 v square is equal to, this is gmm. This mm is the mass of the mass. So this is, on taking LCM, this is Rm and this is Rm plus h, and here this is Rm plus h minus Rm. So this is Rm, cancel by this Rm, and here this is 0.4 v square is equal to, this is g mm upon this Rm into this h upon Rm plus h, and this can be written as 0.4 v square into Rm upon this g mm is equal to this h upon this is Rm plus h, or this can be written as gmm upon this is 0.4 v square into Rm is equal to, this is Rm upon h plus 1, and this can be, this one is here, right? So this is gmm upon this is 0.4 v square into Rm minus 1 is equal to this Rm upon this is Rm upon h, or here this is, now this LCM is 0.4 v square Rm, and here gmm minus 0.4 v square, this v square Rm is equal to this Rm upon this Rm upon h. Now this cross multiply here, so this is gmm minus 0.4 v square Rm upon this is 0.4 v square, this Rm square is equal to 1 upon h. Therefore this h is equal to 0.4 v square Rm square upon this g mm minus 0.4 v square into Rm. Now on putting values, h is equal to, this is 0.4 v is the speed is 2 into 10 to the power 3 this whole square, and the radius of Mars is, this is 3, or you can say 3.395 into 10 to the power 6 meter this whole square, divided by, this is capital G is 6.67 into 10 to the power minus 11, and the mass of the Mars is 6.4 into 10 to the power 23 kg, minus this is 0.4 into v square is again this is 2 into 10 to the power 3 this v square into Rm is the radius of the Mars, and the radius of Mars is, this is 3.395 into 10 to the power this 6, right? Now on solving, this is nearly equal to 495 kilometer. This is the answer of this problem.